Well, in some data sets, particularly those based on surveys, there are often skip patterns. So you may ask participants in a survey, have you ever been arrested? And a respondent may say no. If the next question in the survey is how many times have you been arrested, for a participant who already reported never having been arrested, this second question just doesn't make sense. To avoid asking inappropriate questions, skip patterns are often created in surveys that allow participants to skip questions in which the answer can be logically determined. In this way, missing data on some questions might mean that we can reasonably recover valid information.
For the question, did you drink at least one alcoholic drink in the past 12 months, 16,116 participants said no. These individuals would not need to be asked the question about how often they drank alcohol in the past 12 months.
Instead, they would be set to blank, or in the case of a Python data set, may be set to NaN. So for the variable, how often did you drink alcohol in the past 12 months, it would be reasonable to code this as valid data rather than missing for those saying that they have never drank alcohol. To recover this valid information in our program, we'd add the following statement. So here, rather than left as missing, we're adding a category to the variable S2AQ8A with a dummy code of 11 to indicate those participants who did not drink alcohol in the past 12 months. We also need to include if S2AQ3 not equal to 9 to our logic statement in order to separate the 16,116 no responses to the question, did you drink at least one alcoholic drink in the past year, from the 31 observations whose answer was unknown.
Another very useful step in data management is to give your variables response codes that may be more logical than those they were originally given. For my variable, usual smoking frequency, you can see from the codebook entry that lower values mean that the respondents smoked more, and higher values means the respondents smoked less. Perhaps this seems counterintuitive to you.
We could choose to reverse code this variable so that higher values mean more smoking and lower values mean less smoking by adding the following logic statements.
First, we will create a dictionary that sets the details regarding the values we want to recode. I will call this dictionary recode 1, where 1 will become a 6, 2 will become a 5, 3 a 4, 4 a 3, 5 a 2, and finally 6 will become a 1. As you can see, I am just reverse coding this 6-level variable so that higher numbers mean a greater smoking frequency and lower numbers a lesser smoking frequency in the format old value, new value, with commas separating each. Next, we use the map function to point to the recode 1 dictionary and ask that these recodes be applied to variable S3AQ3B1. Note that I also decide to give this recoded variable a new name, USFreq, USFREQ, so that it is easier to remember and so that I do not confuse USFreq with the original variable S3AQ3B1 and begin to make mistakes when I'm interpreting my output.
But there's actually another option that may be even better for giving this variable codes that are maximally appropriate. In a way, dummy codes 1 through 6 are unnecessarily categorical, given that how often you smoke is generally a quantitative variable, and it may be reasonable to recode the variable in order to capture more of its quantitative features. To do this, we choose values that reasonably correspond to the number of times each individual smokes in a usual month. So someone who reports smoking every day could be said to smoke cigarettes on 30 days in a usual month. Someone who smokes 5 to 6 days a week could be said to smoke 22 days in a usual month. Someone who smokes 3 to 4 days a week could be said to smoke 14 days in a usual month. Those smoking 1 to 2 days a week would be 5 days in a usual month. 2 to 3 days a month would be 2.5 days in a usual month. And once a month or less would be 1. Although these are estimates, they capture the quantitative nature of the measure and also keep individuals ordered in terms of the frequency with which they smoke. Note that the way we've written the syntax, our new variable is called US Freak MO, which stands for number of days smoked in a usual month. So this even makes more sense, doesn't it? What we've basically done is to spread the measurement of smoking frequency out in a meaningful way, so that while it's a categorical variable, we're actually getting more information out of it than we had originally been given. And when we add this syntax to the program and request a frequency table, the table now describes the sample of 1,706 young adult past-year smokers somewhat more clearly by showing the numbers and percentages of individuals who smoked these approximate number of days in a usual month. You can see that the vast majority of the sample, 1,320 individuals, or 77.51%, smoked 30 days a month. Fewer than 5% smoked one or fewer cigarettes a month.